Hello everyone and welcome to your first coding lecture. So in this lecture we're going to be learning about numbers and more in Python. And we're going to cover the different types of numbers that we can use in Python, some basic arithmetic using those numbers in Python. We'll also learn about some differences between Python 2 and 3 when it comes to division. And we'll get a quick peek at object assignment in Python. So here I have open the Jupyter or IPython notebook. So you can scroll through this notebook, check it out if you want to go in a little slower at your own pace. There's tons of information here, and we'll be going over all this in this lecture video. Okay, great. So let's just get a quick presentation on the two types of numbers we're going to be working with, which are integers and floating point numbers. So I'll do a quick break to the presentation. Okay, here we are at the presentation now. And there's a lot of different types of numbers in Python, and we're going to focus on two types right now, integers and floating point numbers. So integers are just whole numbers, positive or negative. So for example, 2 and -2 are just examples of integers. And floating point numbers is the other number type we're going to be concerned with right now. So floating point numbers have a decimal point in them, or they can use an exponential e to define the number. So for example, 2.0 or 2.0 there and -2.1 are examples of floating point numbers. Also 4e2, either capital E or lowercase e, is an example of a floating point number in Python. And all that means is 4 times 10 to the power of 2. We'll mainly focus on those 2.0s and 2.1 type of floating point numbers, the one with decimal points in them. Okay, so let's go ahead and hop back to the code. Okay, and we're back to the Jupyter Notebook. And now I'm going to hop over to our live code session. All right, so here I'm just going to be going over the code that we go in the notebook. So let's go ahead and check out how to do some basic arithmetic in Python. Here I have my cell, and for addition, all you do is you type the number in and put in a plus sign, so 2 plus 1. Remember, Shift Enter to run your cells. And there you go. That's how you can do addition. So for example, 2 plus 2, again, just 4. All right, subtraction. It's also pretty simple. Just a simple dash sign there. And we can do another example. And 3 minus 2. So right now, when we're first looking into Python, we can go ahead and think of Python as just a calculator. So multiplication, the symbol for that used in Python is an asterisk. So there you have 2 times 2. Or 3 times 2 is 6, etc. Okay, so here's where we have to kind of keep close attention as we go into division. And the reason I say that we have to pay close attention is because of the following. So let's say I wanted to do 3 divided by 2. So what would you expect 3 divided by 2 to be? Probably 1.5, right? So if you notice, I'm using Python 2 right now. You can see up here in the right-hand corner. And the output is 1. So why did this happen? And if you hop over to the Jupyter Notebook, you'll notice you get a Python 3 alert here. So what's going on? So the reason we're getting this result is because of Python 2. In Python 2 and Python 3, you perform division using this / symbol for division. But the difference is in Python 2, this symbol performs what's known as classic division. And that means that the decimal points are truncated off. So 1.5 gets truncated to 1. In Python 3, however, this single / for division performs what's known as true division. So you would get a 1.5 if you had inputted 3 divided by 2 using Python 3. So what do we do if we're using Python 2 and want to avoid this kind of floating point error? So there's different methods. One method is that you can specify one of the numbers to be that floating point number. So I can say 3.0 divided by 2, and then you'll notice we get out 1.5, the expected result. And that can work for either number. So 3 divided by 2.0. The difference being just one of them has to be defined as a float. Some other things you could do in Python 2 is also cast one of the numbers to be a float. And what casting does is it uses a function that basically turns integers into floats. So what that would look like, and we haven't learned about functions yet, but we'll get a quick sneak peek, is you can call float like this on one of those numbers. So it's float parentheses 3 parentheses divided by 2. And what that's basically doing is it's casting that integer 3 as a float. So if I check what's going on there by itself, I get 3.0. Okay, so there's one other thing that we could possibly do. And again, this is just a kind of a sneak preview because we haven't gone over functions or modules yet. But a really interesting module that Python 2 has is called __future__. And it'll actually allow you to import some capabilities from Python 3 into Python 2. And we'll go over what this is actually doing and how it's working later on in some lectures. But with this line, division, let's see. So right now I've written down from space __future ___ space import division. If I go ahead and run that line, what that's done is it's imported division from this future module. And what that basically does is now it treats division as if it were using Python 3. So you notice I can just say 3 divided by 2, and now that's corrected to 1.5. So let me just reiterate the 3 different things we can do here. You can make sure one of the numbers is a float, or you can actually cast one of the numbers to be a float to make that happen, or you can run this line from __future ___ import division, and that will take care of the rest of the divisions you do throughout Python 2. So my suggestion is running this line. We'll learn later on in lectures about modules and what this is actually doing and how this is working. But right now you can just kind of treat it as this magic line. So if you're ever going to be dealing with division a lot in your code, you want to go ahead and put this at the top if you're using Python 2. Okay. So moving on to some more arithmetic, how about we check out powers? So for instance, 2 to the power of 3. So the way you do that is by doing double asterisks. So 2 asterisk asterisk, the power of 3 is 8. I can say 4 to the power of, let's say 5, that's 1024. And we can also, if we want to do roots that way, so I could say like the square root of 4, is the same as 4 to the power of 1/2, in this case 0.5, and that's the same as the square root of 4. You can also do square roots by importing the math function, but importing the math module, excuse me, but we'll look at that later on in the course. Okay, so moving along, we can also learn about order of operations that are followed in Python. So your standard order of operations are followed. So what I mean by that is if I say 2 plus 10 times 10 plus 3. So order of operations indicates that multiplication has to occur first before addition. So this 10 times 10 is going to happen before the 2 and 3 get added. So Python's not going to follow this reading left to right. It's actually going to follow order of operations. And I can see that occur due to the 105 result we get there. Okay, so what if I want to specify some orders? I can use parentheses, just as you're writing a math equation in perhaps like a TI-83 calculator. So if I wanted that 2 plus 10 to occur first, I can use parentheses to specify my custom orders there. Okay, so that's the basic arithmetic. Let's do a quick overview. Addition is just the plus sign. Subtraction, just that dash, that minus. Multiplication is that asterisk symbol. Division, /. Careful to note that if you're using Python 2, you're not going to perform true division. You're going to perform classic division, unless one of them is a float or you use this from future import division line. Okay. And if you're interested in some more details on that, you can go ahead and read this Python 3 alert in a little more detail in that Jupyter notebook. All right, so moving along, I'm just going to give you a really quick introduction to assigning labels to objects to create variables. So what I mean by that is I can use a single equal sign to assign labels to objects. So to show you an example of this is I can say A is equal to 5. Sorry about that. And so now I've set a label A as a reference to that number 5. So if I call A in my script again anywhere, Python's going to treat it as if it was the number 5. And I can also add those objects together. So I can say, for example, variable A plus A, and it's going to treat it as if it was 5 plus 5. So an interesting thing that we note in Python is what happens if we reassign this label. So if I say now A equals 10. So Python lets it write over. So now if I reference A, it's 10 now. So you can write over those assigned labels on those variables. And we'll go in on the next lecture into a little more detail in case you're jumping in from another language on how Python actually deals with these labels. But for the basics right now, you can just treat it as you choose your variable name, an equal sign, and then whatever object you want to label that. Okay, and you can also use the variable label itself to reassign the variable. So what I mean by that is I can say A equals A plus A, and what Python will do is now it'll say, okay, so A is now equal to A plus A. So what was A originally? Now it was right now 10. So A is not going to be equal to 10 plus 10. So if we check that out, there we have 20. Okay, great. So you might be thinking, okay, so what are the rules on creating these variable names? And there's a couple rules that they have to follow. So I'll jump over here to the Jupyter Notebook where I have them all. Okay, so these names, they cannot start with a number. There can also be no spaces in the name. If you want to specify some spaces, probably use a underscore instead. They can't use any of these symbols right here. All of these symbols are forbidden, and it's usually considered best practice that the names are lowercase. So let's go ahead and go over a super simple example of how we can use these labels and these variables that we make to clean up our code a bit. So these variable names help us keep better track of what's going on in our code. So to give you a small example, I'm going to make a variable called my underscore income. And I'm going to set it equal to the number 100. And then I'm going to make another one called tax rate. Tax underscore rate. And I'll set that equal to 0.1. Great. And so now, finally, I'll say my underscore taxes that I have to pay is going to be equal to my underscore income multiplied by my tax rate. Great. And if I've run that cell, now I've defined my taxes as my income times my tax rate. And if I call it to see what that value is, it's 10. So 100 times 0.1, that 10% tax rate, my taxes are $10. Great. So what have we learned? We've learned some of the basics of numbers in Python. We've also learned how to do arithmetic and use Python as a basic calculator. And we wrapped it up with a quick introduction to variables and how we can create them and label them in Python. So next up, we're going to learn a little bit more of how this variable creation and labeling works. But go ahead and feel free to just mess around with Python. I think one of the best ways to get a quick introduction to Python is just treat it as a calculator. And then with the introduction of variables and labeled names, you'll slowly get more and more complex with your code. But go ahead and mess around with different additions, multiplications, powers, etc., divisions. Make sure you really understand how to do all those operations, because numbers is going to be one of the main building blocks we work off of in our code. So keep in mind the difference between integers and floating point numbers, differences between Python 2 versus 3 when it comes to division, and all the different arithmetic you can use Python for. Okay, so that about sums up our lesson. Remember, there's always more to read in the Jupyter Notebooks if you want to go into a little more detail over anything. Alright guys, thanks, and I'll see you at the next lecture.